Hello, this is Sadbir. The topic of our discussion in this video tutorial is sets and function. Let's begin with the definition of set. What are sets? Sets is basically the collection of objects. So a collection of objects are known as sets. For example, so I have a set S1 and I have 5 objects in the set, and these 5 objects are my first 5 natural number. There is another definition of set. In this set, instead of a numbers, I have the days of the week. For example, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So these are the 7 day of a week. This is also the example of a set. Then one more example of a set. Set can contain anything. So it can contain number, it can contain symbol, like this is symbol hashtag, or also set contain another set in it. So there is no restriction that the what type of the object a set may have. Let's for one more example of the set. This time I take the weekends. This is, I can call the another set which has the weekends included, Sunday and Saturday. And there's one more example, 5 3 4 2 1. So as you can see that there is no order needed, or no order is required how you place the element in the set. So you can place the element in the set in any order. Our next definition is element. The member of the set are known as element. It's basically the member of the set are also known as element. For example, 2 is a member, and we can say that 2 belongs to set S1 because 2 is the member of set S1, and also 2 is the member of set S5. So this symbol is used to say belong. So 2 belong, or 2 which is the element of the set S1 and S2. And also it is clear that 2 is not the element of set S2 and also S4 and S3. And we use this symbol, basically rounded E with slash sign, to write not belong. It means if some element is not in the set, then we write that basically 2 does not belong to the set S2, S4, and S3. In general, if X is in a set S, then we write X belongs to that set. And number 2, this is a number 1. And if X is not in set S, then we write X do not belong to the set S. So with that symbol. So this is the notational form when we write in journal, that when any element is in the set, or when the element is not in the set. So this is how we are going to write in mathematically notations. Our next definition is subset. So if we have a two set A and B, we say that A is a subset of B. So this is the notation that A is contained in B. if and only if and only if every element, every x belongs to A, every element of A belong to A is also in B. That element is also belong in B. Let me give you a few examples. So let's suppose I have a set S1, which has element 1, 2, and 3. Then I have another set S2, which has element 1, 2, 3, and 4. And then we will say that S1 is a subset of S2 because all the element of the set S1, they are also in set 2. And same time, we can say that S2 is not the subset. This is the notation for the subset not in S1 because not all the element of S2, they are in S1. And for example, 4 do not belong to S1. So this does not satisfy the definition of subset. Our next definition is proper subset. A is a proper subset. We will say A is a proper subset. So the notation from the proper subset is we do not write the this equality symbol. So we say A is properly contained in B if and only if number one is same, the every element, every X belongs to A is also belongs to B, and number two that not all element, not all X belongs to B implies X belongs to A. Not every element of the set B belong to the set A. So then we will say basically A is a proper subset of B. So as you can see that S1 is a proper subset of S2. And if, for example, if I write another set S3, which contain the element 3, 1, and 2, then you can see that S1 is not a proper subset of S3 because all the element of S3 is also in the element of S1. So as you can see that for a proper subset, you need, if S1 is a subset of S2, we must have S2 is not a subset of S1. Then it will be a proper subset. Our next definition is equality in set. We say two set, let's suppose A and B are equal if and only if all the element of the set, if they contain the same element, if they contains the exact same element, or in other word, if A is a subset of B and B is a subset of A, this will implies A is equal to B. You know, for example, you can see that in the above example, S1 is a subset of S3 and S3 is also a subset of S1, or in other words, S1 is equal to S3. Because in S3 and in S1, they have exact same element. And they are all in a different order, but the order in the set basically does not matter. So in even these two have the element in a different order, but they are still considered as a same set. So S1 and S3, they will be a same set. And S1 and S2, they will not be same set because they have one element which does not belong to S1. So S1 and S2, they are not, basically S1 is not equal to S2. So this is the inequalities in these two sets. So our next topic is how to write a set more mathematically. So for example, if I have a set S1 whose element are 1, 2, 3, 4, I can write this set S1 also in a more mathematically representation. And this representation is X, and that two columns means such that X is a natural number. So you can see X belongs to natural number, and X is less than 1 and 4. So all the natural number which are between 1 and 4, they belong to S1. Another example, so let's suppose write the set S2, which is the set of all even natural numbers. So we can write 2n, so that n is belong to the set of natural number. So this set will contain all the natural number which are even. And I also can write the set of all odd number, which can say 2n minus 1, so that n is belongs to the set of natural number, and as you can see that this set will contain all the odd number. For an instance, you can see that S2 contain 2, 4, 6, and so on, all the even number, and S3, which is the set of all odd. If I start n plugging 1, I will get basically 1, and then I will get 3 and 5 and so on. So this is the formula, basically 2n minus 1. So we can use this formula to also to represent the set of all odd number, odd natural number. Our next topic is what are the set operations. So there are three type of set operations we will discuss in this video. Our first operation is union. So union between two sets, for example, we have a set A, and this is the symbol of a union, which is a cup. A cup B is a set which is a define all element such that this T column means such that the element of the set A or the element of the set B. So the union set, it is a set and it is contained the element which are in A or the element which are in B. For example, let's suppose you have a set A, which is a 1, 2, 3, and then you have a set B, which is 3, 4, and 5. Then A union B will be the set which contain all the element of A and also the element of B. 3 is already there, so I will write 5, 4, and 5. Also, you can notice that A is always a subset of A union B, and also is clear from the definition that B is will be always a subset of A union B, because A union B is a set which contains all the element of the set A and also the element of set B. Second operation is intersection. And the notation of the intersection between two set is A cap B, and it is written as in a mathematical notation all the element let's suppose X which are in A and which are also in B. So basically we take all the element which are common between A and B. For example, the example I have above today, the A intersection B is is 3, because 3 is the only element which is a common between A and B. But for example, if I have another set which is starting from 5, 6, and 7, and as you can see that A intersection C now have no element in common. So when there is no element common between the two set, we write it as an empty set with a Greek letter phi. Our third operation is complement. The complement of a set is denoted by A power C, and it contains all the element of the universal set which are not in A. It's contain the element, but they are not in A. For example, if I have a set A which contains all the even number, where n belong to set of natural number, then the complement of the set will be all the natural number which are not even, or in other words, in this case, it will be all the odd natural number. So the complement of the set of even natural number is the set of odd natural number. There is another definition of a complement of B, which is defined with respect to the set B. And this definition is, we take all the elements which are in A, but which not in B. So this is also called the set A minus B. And for example, for this example, which we have here and here, so you can see that A minus B, all the element which are in A but not in B. So 3 is the common element, so that will not be in A complement B inside that set. And also you can find B A. This will be all the element of the set B which are not in A. So this will be 4, 5. So now I have one more remark. So you can define these operation not for just two set. You can define the operation for more than one set. For example, if we have n set A1, A2 up to AN, capital N sets, then the union of these n set can be defined with this symbol where n vary from 1 to n with cup, and it is the set of all element which basically belong to sum of A n, where x belongs to A n for some n belong to capital N. Similarly, we can define the intersection. So intersection of n set, n vary from 1 to capital N, A n, is defined as all the element which are belong to A n for all, which are common between all A n for all I less than n less than n. So which are common in all the A1, A2 up to AN set will be the intersection of all these n set, and it will be denoted by the cap vary from 1 to n of AN. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Our next topic is function. So the definition of the function is given two set A and B, the function f is a rule which connect the set A to the set B, and in that rule, for every element of element x of A associate with a single element, we're gonna call that element f of x of B. So this is a rule that every element of the set A will be associated with a single element, which I called f of x of the set B. Or in other words, mathematically, I can say that if I have an element x belongs to A, then there exists. So this is a symbol of there exist always the element f of x, which will be in B. So this is a more, in a mathematically simple, the definition of the function. Here the set A is called the domain of the function, and the set B is called a codomain of the function. And there is another important definition, which is we know that the range of the function, most of the time it is denoted by Rf, and the range of the function will contain all the element of the set B. Let's suppose y belongs to the set B, and this y is coming from the relation with have the element of the set A for each element of the set A, or for every element of the set A. So this is the definition of the range of the function. So all the elements which are associated with the element of A will be in the range. All the element of B which are associated with the element of A, they will be in the range of the function. Let me give you a few examples of the function. So our example number one is that we have seen in calculus, most of our functions are defined in terms of formula. For example, f of x is equal to x squared. So this is the function which represent the parabola, and it's a function which connect the set of reals to the set of positive reals. For all the positive real numbers, because here you will never get a negative number in the codomain. So this is a set which connect the real number to the set of positive real number. And you can also graph this function easily. So this is the graph of that function. The second example is very interesting for us, and this is introduced by Dirichlet, and we will be going to use this example a lot in our course. And this time, these examples do not give you a formula of the function. Instead, it is defined as a signal 0 and 1 if x is belong to a rational number, and if x do not belong to a rational number. So as you can see, this function connect the real number to the set, which is only contain 1 and 0 element. And to draw the graph of this function will be really hard, and which we will see in our next coming video, that we will try to attempt to draw the graph of this function. However, we will use these examples in many results to basically sometimes to disapprove some results. So this is the most important example for us in this course. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video.